Yes, here we go into another video on improper integrals. In this video, we're going to focus on looking both ways before crossing the improper integral street. What do I mean by that? Well, if you've got an integrand, right, a function you're taking the integral of, where that function may have a discontinuity, like a vertical asymptote discontinuity, in the boundary window, then we might need to use improper integral rules. What the heck do I mean? Well, if we take a look at this integral, it's from 0 to 1, right? And at first glance, we're like, oh yeah, no problem. Except this bound right here, if we plug that in, that would give us 1 over the 4th root of 0, which is equal to 1 over 0, which means one of the y values on this curve over the interval that we're looking at goes to infinity, right? We've got an infinite value there, so we need to take a limit. And the question is, what kind of limit though? So we're taking the limit again as a approaches. Now we're not just going to approach 0. We're going from 0 to 1, which is from left to right. So we're going to approach 0 from the right side of it. If you take a look at the graph here, we're taking all the area just from the right side of 0 all the way until 1. And we're asking ourselves, is that area finite? Does it converge or does it diverge? So we've got to take the limit as a approaches 0 from the right, from a to 1. And I'm going to rewrite this as x to the negative 1/4. Okay. Now, in this case right here, we've got ourselves finite limit, but something that's causing an infinite value. So again, be on the lookout for those. Anytime you get a number over 0, that's where we need another limit. Okay, so now we're going to just integrate this like normal. We'll get the limit as a goes to 0 from the right, we add 1. That's not so bad. The integration's very easy. X to the 3/4, and then we divide by that. We get 4/3 evaluated from a to 1. Okay, so let's go ahead and evaluate that. So that's the limit as a goes to 0 from the right side of 0. We're going to evaluate in 1. So that's 4/3 times 1 to the 3/4 minus, just the first fundamental theorem, minus, and then that's going to be 4/3 a to the 3/4. Now, from here, we evaluate 0 from the right into that. So we're going to end up with 4/3, because 4/3, 1 to the 3/4 is just 1, minus 4/3, 0 from the right side. That's 0, right? It's basically 0 from the right side, but that's 0 to the 3/4 is still 0, times that is 0. So our answer is 4/3. So we get a finite area, and our conclusion, therefore, is that that integral converges. Not so bad. Not so bad at all. So what that means is this area is finite. The reason being is we're not approaching the vertical asymptote fast enough here. I know we went over rules in video 1 where I said, well, this power needs to be, let's see, at the end of the day in this denominator, greater than 1. In this case, that's not the case because we're not looking to go to infinity with the x value, right? We're going to a finite value, which is different there. So just kind of mentioning that. And again, you don't need to memorize the rules. Follow your improper integral instincts that I've been teaching you and you'll be okay. Do another one. So, final one in this video is one where we have an improper bound on the interior. What does that mean? At first glance, we could plug 0 into this. You get negative 1. Squared is 1. No problem. 3 minus 1 is 2. Squared is 4. No problems. Except x equals 1 gives a vertical asymptote. Right? So we got a vertical asymptote at x equals 1, and that's on the interior here. So we actually have to split open this integral, and as you can see from the graph, if we're finding the area from 0 to 1, we need to mind both sides of that vertical asymptote. So that's the area that we're looking for, all of this. We want to know, is it finite or infinite? So we got to split this up into two integrals. We'll take the limit as a goes to 1 from the left side, right? You're approaching 1 from the left, from 0 to 1. So that's from the left side of 1. And that would be of the integral from 0 to a of 10. And I'm going to rewrite that in a way that makes it easier to integrate. X minus 1 to the negative 2 dx. And I suppose there should be a dx there. How about that? Plus the limit. Now we're going to come from the right side of 1. So we've got b. Need a different letter because it's a different limit from the right side of 1. And that'll be from where we left off at 1, which would be b, to 3. and that would be 10 times x minus 1 to the negative 2. So again, we need to split this thing up into two separate integrals because we're approaching one from the left as well as from the right. Now, if this thing diverges, you do not need to check the right side. The whole thing will diverge. If this converges, we need to go and check that one. Let's do it. So we get the limit as a approaches 1 from the left side. The integral of this is not bad, actually. It's 10 times, we'd add 1 to this, x minus 1 to the negative 1 divided by that negative 1. That's it. There's your integral. You could use substitution. I'm going to try to avoid it if we can. Since there's no value on the inside here aside from 1 times x, the derivative is not so bad. So I didn't need u sub to know the derivative of this is that. We're going to evaluate that from 0 to a. Okay, let's do this. So the limit as a goes to 1 from the left-hand side, and that's going to be negative 10 over, and I'm going to start to plug in things. We'll plug in a. So the negative 10 comes from negative 1 and the 10. I put it over because it's x minus 1 and the negative 1. We're going to get a minus 1, that's to the negative 1, minus the minus 10 will be plus 10 all over, and then we're going to plug in 0. 0 minus 1. Okay, so this is not a problem right here. Right? This is not an issue at all. But let's see what we end up getting out of all of this. We're going to 1 from the left. That's going to give you negative 10 over, well, basically 0 from the left. Why from the left-hand side? Well, when you plug in 1 from the left, it's like plugging in 0.99. Minus 1 is a very tiny negative number. And so a negative number over a very tiny negative number is going to go to a very big positive number, right? Tiny negative, big negative over tiny negative, hugely positive. And that's it. So therefore we diverge. The first piece of that integral diverged. We don't need to check the second one. And that will diverge as well, by the way. Sweet. That's it. So you always need to look both ways. If you have one of the bounds themselves causing you to get a number over 0, then you know you need to approach that number from the proper side. Either from the right side if it's on the bottom limit, or the left side if it's approaching from left, obviously. Now, don't be so sure that just because the bounds work in your integrand that we're in the clear. You should then look to see what causes vertical asymptotes in the integrand. And in this case, we said, oh, 1 does. And 1 is between 0 and 3, so we need an improper integral. If our bounds were like 5 to 7, no issues. No vertical asymptotes in that interval, so we could just take a normal old integral. All right, we'll leave it at that. I'll see you in the next video. It's going to be a good one. Peace.